Problem 3 asks us to find the area of the graph, or the region between the graphs of f of x equals 3x cubed minus x squared minus 10x, and g of x equals negative x squared plus 2x. So I don't, off the top of my head, know what these two graphs look like. So we're going to try to do this algebraically. So the first thing I need to do is find the intersection between the graphs. And I do that by setting my two functions equal to each other. So I'm going to bring my x squared over. So negative x squared plus x squared gives me 0. So these cancel. And then I'm going to subtract 2x from both sides, and I get minus 12x equals 0. I can factor a 3x out of this, and then I have a difference of squares, so I can factor it one more time. So this says that x equals 0, negative 2, and 2 are my points of intersection. So now I need to see, well, which one's bigger where? So I'm going to set up a table, and I'm going to put these x values in numerical order. And then I'm going to evaluate f of x at each of those values and g of x at each of those values. So if I plug negative 2 into f of x, I'm going to get f of negative 2 is going to be 3 times negative 8 plus 4, minus 4, plus 20. So negative 24 minus 4 is negative 28, and negative 28 plus 20 is negative 8. G of negative 2 is negative 4 plus 2 times negative 2, so I get negative 4 minus 4, I get negative 8. So they're equal, and so we know we've correctly found my points of intersection. So the same thing's going to happen here. If I plug in 0, I get 0, I'll get 0. If I plug in positive 2, I'm going to get f of 3 times 8 minus 4 minus 20. So 24 minus 4 is 20. I get 0. And g of 2 also gives me 0. So this is how we know if you need to check we found the correct points of intersection, because these should all be equal. So we know that we factored correctly. Now we want to see, well, which is top versus bottom. So what I need to do now is I need to pick values in between these and test them. So if x equals negative 1, f of negative 1 is negative 3 minus 1 plus 10. So I get negative 4 plus 10, which is 6. G of negative 1 is negative 1 minus 2, or negative 3. So f of negative 1 is bigger than g of negative 1, so this is the top function. This is the bottom function. If I pick x equals positive 1, and I'm picking values between 0 and 2 here, f of 1 is 3 minus 1 minus 10. So that's 3 minus 11, which is negative 8. And if I pick g of 1, I get negative 1 plus 2, which is positive 1. So now g of x is the top, and f of x is the bottom. So the area between my curves, the area is going to be the integral from negative 2 to 0 of the top function minus the bottom function, plus the area from 0 to 2 of my top function minus my bottom function. So what we can do is, if you go back, we can kind of look at our work up here. We can kind of done some of this hard work ourselves. So since this was f of x and this was g of x, this line of my algebra right here, I took all the terms from g of x and subtracted it over. So this is f of x minus g of x. So if I come back down here for my first integral, I can say, well, this is just 3x cubed minus 12x dx. If you reverse the order of subtraction, which is all we did here, it just changes the signs of all the numbers. So this is negative 3x cubed plus 12x dx. So now I just evaluate these integrals. So 3x to the 4th over 4 minus 12x squared divided by 2, which is 6x squared, and I evaluate that from negative 2 to 0. This is negative 3x to the 4th over 4 plus 6x squared, and I evaluate that from 0 to 2. So when I plug in 0 here, I get 0 all the way across. Minus, when I plug in negative 2, I get 3 times 2 to the 4th, which is 16, divided by 4, and so this works out to be positive 12. When I plug in negative 2 here, I get 4, and 4 times 6 is 24, so this is 12 minus 24. Here, when I plug in 2, I get negative 12, and I get positive 24, and then when I plug in 0, I get 0. So this is negative 12 plus negative 12 plus 24 is positive 12. And so the total area is 24. If you were to put this in Desmos and graph it, just to confirm what we did, the graph looks like this. So here's our axis. Here's f of x. It intersects at negative 2, 0, and 2. And here's our graph of g of x. So we can see that between the region of negative 2 and 0, f of x was on top, so that was the region we found. But then when we went from 0 to 2, g of x was on top, and that's why we had to reverse the order. So even though we didn't have the picture, all of the steps we did confirm that for us.